Translucent concrete by using fiber optic strands. Transparent concrete is the new type of concrete introduced in modern era which carries special property of light transmitting due to presence of optical fiber strands and is also known as translucent concrete or light transmitting concrete. Light is transmitted from one surface of the wall to the other due to the presence of optical fibers along the overall width of the wall which allows light to pass through. An optical glass fiber strand is a flexible, transparent fiber made of silica or plastic, slightly thicker than a human hair and can function as waveguide, or light pipe to transmit light between the two ends. Main aim of the study is to design translucent concrete blocks with the use of optical fiber strands with mortar and cement and then analyze their various physical and engineering properties with respect to conventional concrete blocks by adding optical fibers of 3%, 4% and 5%. In this project, we will check and perform tests on compressive strength and light transmittance property of translucent concrete. The principal objective of this project is to design translucent concrete blocks with the use of optic fiber strands and then analyze their various properties and characteristics. All tests further performed on the translucent concrete samples are done to ascertain the improvements of the cast blocks over normal concrete blocks of the same size and with the same design ratios, and to ascertain practical utility of using translucent concrete as a building material. Introduction. Concrete has been used since Roman times for the development of infrastructure and housing, but its basic components have remained the same. Three ingredients make up the dry mix: coarse aggregate, consisting of larger pieces of material like stones or gravel; fine aggregate, made up of smaller particles such as sand; and cement, a very fine powder material that binds the mix together when water is added. Just a few decades ago concrete was often misunderstood, disliked, and captured by its image fixed due to the rapid urbanization of the 1960s. But since that time, concrete has made considerable progress, not only in technical terms, but also in aesthetic terms. It is no longer the heavy, cold, and gray material of the past, it has become beautiful and lively. By research and innovation, newly developed concrete has been created which is more resistant, lighter, white, or colored, etc. Concrete has learned to adapt to almost all new challenges that appeared. In 2001, the concept of transparent concrete was first put forward by Hungarian architect Aaron Losonzi at the Technical University of Budapest, and the first transparent concrete block was successfully produced by mixing large amount of glass fiber into concrete in 2003, named as Litrocon. The transparent concrete mainly focuses on transparency and its objective of application pertains to green technology and artistic finish. It is the combination of optical fibers and fine concrete. At present, green structures focus greatly on saving energy with indoor thermal systems. Therefore, it is imperative to develop a new functional material to satisfy the structure in terms of safety monitoring, such as damage detection, fire warning, environmental protection, and energy saving and artistic modeling. Due to globalization and construction of high-rise building, the space between buildings is reduced. This causes to increasing the use of non-renewable energy sources, so therefore there is a need of smart construction technique like green building and indoor thermal system. Translucent concrete, transparent concrete, is new technique different from normal concrete. Translucent concrete allows more light and less weight compared to normal concrete. The use of sunlight source of light instead of using electrical energy is main purpose of translucent concrete, so as to reduce the load on non-renewable sources and result it into the energy saving. Optical fibers are a sensing or transmission element, so decrease the use of artificial light. The normal concrete is replaced by translucent concrete, which has natural lighting and art design. Energy conservation is a key and emerging global issue for sustainable infrastructure development. The building sector energy demand accounts approximately 34% of the world's energy demand. Artificial lighting consumes around 19% of the total delivered electricity, worldwide. The electric lighting demand has constantly been increasing with the increase in the population, urbanization, and construction of high-rise buildings. The production of electricity contributes to the increase in the greenhouse gas emissions. According to EIA report, the total CO2 emission related to lighting was approximately 7% of the total global CO2 emission in 2005. A lot of efforts have been made to reduce the energy consumption of lighting by fabrication of energy-efficient lighting equipments, improving lighting designs and using lighting control systems. Translucent concrete is an innovative solution towards significantly reducing the need for artificial lighting. This in turn reduces the carbon footprint by allowing transmission of natural light into buildings' interior when the translucent concrete is used as structural facades and architectural walls, thus fostering the development of green buildings. Natural light is a form of energy reflected as electromagnetic wave that contains full spectrum of the sunlight, which is healthy for human beings and a preference than artificial light. Indoor environments with adequate natural light illumination have been proven to decrease stress of occupant, improve visual comfort and render better employee retention. It is then essential to develop a new type of construction material, which can allow transmittance of appropriate luminance level of natural light into buildings and integrate the concept of green energy saving. Experimental program. A materials. Cement. The cement used in this experimental works is 53 grade ordinary Portland cement. The specific gravity offacement was 3.14. The initial and final setting times were found as 51 minutes and 546 minutes respectively. Fine aggregate. Fine aggregate was purchased which satisfied the required properties of the fine aggregate and conforming to Zone 3 as per specifications of IS 383:1970. Fine aggregate. Fine aggregate is the inert or chemically inactive material, most of which passes through a 4.75 mm sieve and contains not more than 5% or coarser material. The specific gravity 2.75 and fineness modulus of 2.80 were used as fine aggregate. Fiber optic strands. The fiber optic strand used in this experiment slightly thicker than a human hair. It can function as a waveguide, or light pipe to transmit light between the two ends. The diameter of one fiber optic strand equals 0.5 millimeters. Water. Water is used in the study is tap water free from dirt and oil. B. Preparation of light transmitting concrete specimens. In this study wooden molds with the perforated wooden sheets with varying number of drilled holes were attached to the cube molds for accommodating varying percentage fiber optic strands. Molds with fiber in place. Perforated wooden plates. Methodology. M20 grade of concrete was prepared by mixing cement and fine aggregate as per proportion of mix design. Also preparation of molds and installation of fiber optic strands in the molds in the study wooden molds of size 100 mm x 100 mm x 100 mm were prepared with varying number of drilled holes to accommodating varying percentage of fiber optic strands. They were tested for compressive strength and light transmittance property after required curing period. Light transmittance test was performed to study the light transmittance characteristics of the specimens. It is very important test since the main purpose of translucent concrete is to transmit light. Drying of cubes after casting. Curing of cubes. Cubes after curing for 28 days. Sunlight passing through cubes. Light transmittance property test 100 W, 1500 lumens, incandescent source of light. Conclusions. From whole study it can be concluded that the light transmittance up to 6.69% was achieved by using 5% plastic optical fibers. This can be further increased and light transmitting concrete can be used efficiently in green buildings. It can ensure natural light inside the buildings throughout the day. Based on compressive strength test results, it can be said that strength of higher grade light transmitting concrete is not significantly affected by inclusion of POFs. Light transmitting concrete requires skilled labor for its production, as POF should be properly placed in concrete, and special attention is needed while placing concrete, to ensure no damage of POFs. Light transmitting concrete can be used in structures to make them architecturally and aesthetically beautiful, as various types of glowing patterns can be made with this concrete. Cost of manufacture of light transmitting concrete is also high due to plastic fiber optic strands used and special care is required during its preparation. But its cost is fully justified because of its usefulness as eco-friendly, energy efficient, aesthetically beautiful on sustainable ground.